guys, today we are doing the second part of the Smart City series video, and today we are at the SatSure office and KaleidEO office. Let's talk to the founders and understand what is space tech, what is remote sensing, and how do they see use cases emerging out of it, and also seeing what are the real problems, and also understanding the value chain, right? Like first we'll understand the value chain, then we'll go deep to understand the problems and all. So over to my colleague Vishnu to start the conversation.
Hello Pratik, hello Arpit.
Yeah.
So let's start with the basics, right? Like what is remote sensing and what is space tech remote sensing, why is it needed, and what is an umbrella overview of what Satsure and KaleidEO do?
That's a great question. Thank you, Vishnu. So let me start with a very basic understanding that we anyway have without any space or non-space. We are able to act on things that we can measure, right? And we are speaking of us going through already planetary scale challenges like climate change, sustainability. That is not just a problem for one country, it's a problem for the entire humanity. And that is where the entire aspect of collecting data at planetary scale comes in. And this is the place where satellites have a disproportionate advantage, where using these satellites, you can capture information about the Earth and changes that are happening, not only at a global scale in a very short span of time, but with a information density that is as small as just about half a meter on Earth. So this is the reason why Earth intelligence, as they call it, is a very critical facet of us as humanity progressing forward, because we need this data to measure the things that are important for us in making such transitions.
Got it. So you mentioned about measuring things, right? How does this journey start, right? Like where does the process of measurement start? Is it from the satellite, and how does the value chain look like?
That's a very interesting question. Let me answer it on two fronts. Think of it like two dots that are sitting at different locations. One is from the satellite part of things, where we are designing the systems of capturing information in different bands of the electromagnetic spectrum. But how do we decide which ones are important and which ones aren't? So that is the second part of the dot, which is the user. Who is the user? Who is going to be actually measuring that? That comes from the business side, these KPIs, right? So when the two meets, then only we actually say that yes, this is our joint mission, that I am going to measure, for example, methane at a small farm level to act on emissions that are happening due to, let's say, paddy fields. So that is how a satellite engineer, remote sensing analyst, and the final user, who might be an intervention specialist like governments or policy people, come together.
So it starts with the hardware, which is the space, right? Like how does all it moves down to Satsure, where you use multiple sources of data, like we spoke, right, to actually help the customer, let's say in cases of agriculture, let's say in cases of banking, right? But this happens at the ground level, but how it starts from the space to the bottom, right? Like, because then we're able to understand KaleidEO's role and then Satsure's role better.
Absolutely. Let me speak of what has happened in the past. It has always started from the space side for the space tech, because the space industry has operated more as a government prerogative, right? Commercialization of space is a fairly recent, like decade or decade plus just phenomenon.
Correct.
So the degree of separation between the stakeholders within the space industry was very, very high against the stakeholders of the agriculture industry. Now there have been so many missions since 1970s, like Landsat, etc., which were designed for it, and it has created immense amount of value in planning, resource allocation, etc. But we are today speaking of problems that are very different than planning. We are speaking of problems of securing future of people against climate change and the impact of it, and that completely changes the way the decisions at the space technology side or the satellite side are to be taken. And that is where the top down approach from space to earth is changing, and we are proud of being part of that, where a bottoms up approach of what is required on the field is becoming a part of your requirement engineering within the.
So you're doing Earth to space.
We are doing Earth to
Yes.
space, not space to Earth. Maybe he can answer a bit on that.
You were also mentioning that traditionally government, it has all been government led, right? You have space agencies of nations, and there was all this space war in the 70s, 80s, and sort of overcrowded that space. Now, especially when you're going from the market side, like how is the outlook different? And like, for example, you're speaking about KaleidEO being your own crack it, like having your own satellite for specific use cases, right? How does that work? How do you discover what is valuable to it and put meaningful products in space, right?
I'll probably use the same tool that he used, right? So you have this sensor, he said 2 dots, right? So you have the user side of, or the business side of requirement, and you have the technology that enables. And finally, when they meet together, it's where the solution is created. Traditionally, this part of the thing is technology driven. There is typically no feedback from what needs to be sent here based on the user requirements. And this is essentially because of the disconnect that the market is always ahead or probably lagging either way from what the government wants, right? Typically it's the captive requirement of a government that already pre-existing, and what needs to be done over, let's say, a decade-old long policy or a 2-decade policy or something. It's not evolving. So there is always a gap. What we are really trying to do in KaleidEO is essentially how fast can we go meet over here, change this gap in the meeting the solution by rapidly iterating and bypassing all these interactions and layers in between by being under one roof now, so that all this market feedback is immediately translated into a hardware solution. So imagine, like, somebody is, as you said, right, a methane requirement. Now imagine somebody just came to you and told you that I want to monitor methane at probably a 10 meter by 10 meter level, right? That's the extent to which I want the degree of accuracy, and solution is what's the amount of methane also that's coming out. Can you give me those? Now how do you go about designing a hardware from that? Now that's the unique capability that we're trying to build, is translating a simplified business requirement into a more complex hardware translation, and then going through the realization part of it.
Interesting. And just picking off from there, right? Like methane being an extremely hyper-local solution when we are looking at, and also again traditionally mostly space industry or remote sensing has always been about like either typically about communication or like largely defense and like military use cases, right? Like now that we are moving towards this hyper-local location intelligence reality, like what are the new things that you have been envisioning, and what are currently you are working on, as well as what will be coming up in the future at an extremely small scale?
So there are a few things where we have gone very deep. So for example, one of them is enabling credit to smallholder farmers. Now just a few stats, we have approximately 1.4 to 1.5 million square kilometer of arable land in India, and again about 45 to 50% of our population engaged in agriculture, but 80% of them have land holdings that are less than a hectare. So that's a smallholder farmer definition. Now, they are the ones who are most affected by natural disasters like droughts, floods, etc. So what's the kind of financial security that needs to be available to them at the right price at the right time? One is obviously the social security measures that insurance provides, that the erosion of income is compensated through such financial instruments. The other part is ability to invest in their farms and improve the productivity despite the small farms, right? And for that you also need to have some amount of credit, because the income today that a smallholder farmer makes in a year is not more than 50-60,000 rupees. This is after all the costs etc. incurred. So hence we saw this as a very hyper-local problem which has to be solved with scale thinking, because we are speaking of such a big land with so many people. And hence to understand how banks underwrite risks, what are the factors contributing to the risk? It is availability of water, productivity, access to markets, and it is not just satellite data. And this is coming back to your previous question, that satellites are a means to achieve something, but not the only means to solve a problem. We have to think of problem solving first.
They are tools basically.
Absolutely. The problem has to be solved, and yes, satellites are playing a very important role in scaling this risk underwriting, because you can scan earth at scale with a very high degree of precision, point, almost a point solution here. You can go back in time. Risk is all about history,
Yeah,
right?
temporal logistics.
Finally, you integrate it with so many other data points, whether it's a price of the crops that at which it's being sold, the government is setting it, land records, etc. Then it makes a complete journey for a farmer that, hey, what would take ideally a 45 days for me to lend to a farmer can be a 10 minutes journey, right? So this is how the integration of a problem statement and the technology tends to happen, and this is one of the key areas. Now, what are the possibilities to answer your question? Multiple. To be honest, if you ask me today, I may name 5-6 that are very deep problem statements, but there are maybe hundreds of deep problems like this which are yet to be explored, because we are at a very nascent stage of commercial space thing.
Yeah.
For example, some things like water conservation efforts, plan which is not a rural thing, it's an urban thing also. For
Yeah.
example, take Bangalore. What is the how much amount of surface water we had 10 years back? What is it now? How do you act on encroachments? How do you recharge of the
Yeah.
surface and groundwater? A lot of this information is also collected by satellites.
Yes.
Here.
Yeah.
So things like forest and forest conservation. We are speaking of carbon transition here, right? Forest will span such huge swaths. You cannot go and manually collect data. Most people will end up fudging that, right?
And most likely it will be inaccessible as well.
Inaccessible as well.
Absolutely.
So a lot of the forest conservation and forest management activities globally, including in India, are happening with satellite data as the core form of data collection. Same goes for infrastructure, critical infrastructure. We see all of this now sudden, flash floods, etc. happening. This is climate change. 1 month's rainfall in 1 day.
Yes.
Okay. So how do you help the stakeholders understand and manage this risks better in terms of how the routing of these assets should be done? For example, if it's road or power lines, etc., critical infrastructure. There are multiple such applications, and we do a few of them. There are thousands of companies across the globe who also specialize in stuff like, for example, only water quality assessment someone is doing. Someone is doing work on resource exploration. So yeah, that's a very broad answer.
If you think it in a more temporal perspective, there is a more long-term structured solution, right? Which comes from surveying, planning, and then execution of policies to final realization. That's a more long-term one. That there is a part that satellite plays there as well. But there is also a risk mitigation which is talking about, which is what you do in the short term, because there is only so much a finite structured policy can do in a short term, right? So for that kind of a tactical perspective, right, you are mitigating something that you know is going to probably at some trigger event happen. Right, those kind of eventualities can also be solved as well from a satellite perspective.
Just to give an example on that, it could be something like a drought. If you could foresee based on temporal data how it's going to impact the farmers and anything, can you shed a little bit more light on that?
There is to a certain extent what we can call as a predictive analytics, but it's still a miracle solution to expect satellites to solve predictive analytics to that context. So what we rely rather is more on data fusion, right? As you said, right, we rely not just on satellites, it's just one, because of the scale to which it can reach and the aggregated statistical methods which we can apply, because we can see a larger area. We have correlations that we can lean on by understanding how it has happened in the past as well as spatially, like in other locations, like translating those learnings, how we can do something like that. But it is still always a statistical method, is a prediction. Now to accurately say that yes, it will happen, we're shooting somewhere.
So the TLDR version for the audience would be that satellite data provides probabilistic estimations, not deterministic.
Deterministic, yes.
Correct.
So we understood, we identify the problem first, which is what we want to do in this effort on smart cities, right? Understand the problem, then use satellite data as one of those things combined with rest other data sources, and then using AI to maybe generate meaningful insights, right? How can people, like for example, if we have a small working group which is tackling a particular problem, where can they look at the satellite data to just experiment, to start dabbling around, right? Like not just people who are just contributing to this, right? Anyone who's sitting at home who wants to just like how we go to maps, Google Maps, right, and just see, okay, fine, this is how the street looks, this is how it looks. Now, how can they dabble with satellite data?
It's a great example you gave, Google Maps. I think both Google Maps and Google Earth kind of already made satellite imagery a commodity. So what you see as a maps is nothing but stitching together of different satellite images here. So it is giving you a top view of stuff that you would otherwise not have, and it is overlaid with information of location like addresses, shops, this, that, which helps you to determine so many different problems. For example, look at FMCG and all, they do targeted ads based on weather data and this kind of location intelligence. Even your food delivery etc happens on maps, and at underlying the maps is satellite imagery only, right? So what can we do more? A lot. Where do we find the data? I think Google is a great platform to find this kind of satellite images, and a lot of open data today is also made available by satellite operators. We also plan to have this kind of community building efforts driven through imagery that we will be generating at KaleidEO, and it should be a next degree value addition beyond what we anyway do on a Google here, meaning that how do you go into routing of, let's say, a gas pipeline and remove the necessity for cylinders at home. So we are already doing that. For example, organizations like Adani Gas and all are doing that, right? But it's such a complex problem looking at a city landscape, right? What do you need information for? You need the information of how a hub spoke model will work. So you need to know the population density, the elevations of the buildings, the density of the clustering of the buildings, etc., the maps of the underground cables, etc., that have gone. All of this comes together and ends up creating what we say as the smart city planning. So satellites are a part of it, not the only thing, but it's an accelerator for doing this kind of stuff.
So to start with, so for people to start with, somebody who's sitting at home is like, hey, I just want to explore and maybe see what it is. It's like normal maps are the good place to start with.
A Google Earth Engine kind of a thing, and then probably utilizing some community kind of approach where you take learnings from standard GitHub repositories and things like that. There are very, very nice blogs and communities that are built around it. You have even like at the top of my head, what I can think is like OpenStreetMaps community. OSM community is a great community. It's an example of how they're leveraging their community knowledge to do something bigger than what each company can do. Right?
So I'll really give you an example just out of the blue. If I am someone who is interested in building my community, and Google Maps is accessible to everyone today, Google Earth Engine is also accessible to everyone. Let's look at what is the difference in air quality between my neighborhood and a neighborhood other place. And is that difference in air quality coming because the ratio of buildings to trees or greenery is different, which means I have now data to show to all others that, hey, look, if we plant these many number of trees over the next 10 years, we will also have slightly healthier air. Simple.
So it's not just about the data and everything, but the lens which you look at it, as well as the what action do you map it to.
Absolutely.
Focusing on that, like transitioning into that, basically the kind of use cases that come, right, more towards the public side, and more what are the use cases that come on the public side and towards the enterprise side mostly, and also with satellite data and everything getting a little bit more democratized over the next 5-10 years, like even for like businesses as well as like city governments, what are the solutions do you foresee opening up to?
So in US, for example, where satellite imagery is very widely used, it goes for both kind of community action, like the example I gave earlier, as well as it goes for governance. For example, taxation, proper taxation. See, the pressure on cities to invest in their infrastructure finally boils down to how much money they are able to make, and there is so much amount of tax evasion that happens. This is something which is widely used in the US, and I see that in India also the uptake of such measures are accelerating. Bureaucrats themselves are coming with like, I need this, I want to see who has constructed a swimming pool and not paid the tax for it. Okay, stuff like this. But yeah, there is, I think in general, citizenry and governance both enhances, because satellite imagery, which is public, becomes an equalizer. It gives the power to both the citizens to ask the questions on governance, and the bureaucrats to execute the governance better.
Now we are moving to the second part of the video. Now we have Rashmit and Akash with us to dive a little bit on the technicals of it, right? Like now we understood earlier in the first part, like what are the business angle and how does the earth to space approach works, right? Now over to Akash and Rashmit. So to start explaining the value chain, right? Like from how does it start from the, I mean, we understood like earth to space, the business problem and all that but from a technical perspective, how you get the data from the space, from a satellite, and how it is converted to meaningful insights by the tech team here at SatSure, right? So could you please elaborate on that?
So I think the journey starts from the business, like where the requirement is, right? Like, I mean, where do we want to image? First, we need to identify on this whole globe, where do we want to image? Once we know where do we want to image, why do we want to image that? And what is the application? Then you define like what kind of sensor suits for that particular application, where do we want to image it. For an example, if you want to monitor a farm just to find the farm area, it's a very simple problem. For that, if we can go for a multispectral imaging sensor. And when I say multispectral imaging sensor, it is very similar to what our human eyes see around us. It's a combination of red, green, blue colors. With addition, I would say there are some couple of other bands that we can image when we call as a multispectral sensor. Once we have identified where do we want to image, you know, based on physics, thanks to Newton and others, we can accurately calculate where the position of the satellite in the orbit will be, where we want to image, and you have a network of ground stations on the earth. So we send a command to the ground station sends a command to the satellite when the satellite is up in the air. When the satellite is visiting over a particular area, it takes an image, it stores the image on the satellite. When the satellite is again coming towards the ground station, once it's above the ground station in the view of it, we downlink the data from the satellite. The data from the satellite comes to the ground station, or what we call as the server or the cloud on the ground station. It is further transferred to the respective cloud servers. Earlier it was like a very elaborate process where people used to request data over CDs or such kind of things, but now things have evolved where you translate data from the ground station and back to the user. So that's the whole journey of the data. From the user, that is where I think Rashmit takes over in translating into insights.
Before getting into what is satellite data, what is getting captured, what Akash covered more from the optical point of view, which is your multispectral. But think of it this way, that the normal camera, that it captures the image, it's coming in 3 channels, which is your red, green, blue, what our human eye can see. Whereas when it comes to satellite data, the information density is higher. Reason being, the information is captured into different electromagnetic spectrum. Example would be NIR, which is your near infrared, shortwave infrared, right? Now, it is essential that what type of use cases that you're trying to solve. Akash took a great example of farm monitoring, which is just an identification of how much area is it. I can do with go with, let's say, RGB image, where I need to see where the features are, something what you see in your Google Maps, right? But when it comes to what is happening inside that farm at crop level, what type of crop it is, right? That is where it is essential that information gets captured into different electromagnetic spectrum, because the information density what other band provides is essential to identify what is happening at a feature level, right? Initially, the geospatial industry has been very conventional in terms of doing things much more traditional way. And if you look at the journey of how the tech stack has evolved, the more number of satellites have been launched. Now, what was military intelligence before has become commercial. So, the company like us can utilize that data. But what are you going to do with that amount of data? That means your compute has to improve. Your cloud storage cost has gone down tremendously. That also means that, which was like 15 years, I can under $1 million, which was the cost of storage, compute, right? Now it has gone into pennies, right? That's one set of innovation that has helped. The other innovation, the final, we will be talking about AI/ML, right, and what role it has played. type of innovation that is happening, not just in the field of geospatial, but in every domain, medical science, take health industry, right? It has evolved. The type of research that are happening on a daily basis, like 1995 new papers are getting published, right? And really good cutting edge, right? All these have enabled us to think of geospatial as something which is not traditional, but you can actually build a product around it. Something like rinse and repeat. And you can actually cater to the business need, what end customer wants. I would say our USP is not just to build the AI/ML model or the engineering stack around it, but also to do that last mile connect. Our tagline is make space data consumable in the form of a decision intelligence. That is very important, right? Everyone would build AI/ML model, generate some beautiful maps and all those things. Unless you make it in a consumable form, like a number, which helps them to better decision making process. This is where what we do. So if you ask me what type of tech and tech stack that we have built, I would say we are working at an intersection of your geospatial domain, your software domain, and AI/ML domain, because none of them could work without each other. So that's how, and this is how we have tapped into different applications, agriculture, infrastructure, and utility. But at the end of the day, process remains the same. Understand what are the business limitations, understand the business process, build the product around to identify those limitations, to cater those limitations, and then scale it.
Interesting. So expanding upon that, right? Like if you could take any certain use case and maybe one pixel on land, and can you take us through the life cycle of that specific, right? Like from right before it getting sensed to how it is being displayed as an actionable, digestible packet, as you just said. Could you take us through what happens in the backend?
Sure.
Yes.
So let's say I want to identify what type of crop it is, or the event during the crop monitoring stage, right? There's something called vegetation index, which is your just a combination of different bands and subtraction. NDVI, that's another example, which is a proxy of presence of vegetation on a satellite data. You can literally create a digital twin of what's happening on the ground using a satellite data, something called phenology curve. Over the period of time, every pixel, if you start plotting that NDVI over a period of time, you get something like a bell curve. That bell curve, you can literally use it to identify what events are happening. At the start of the bell curve, it will be like you're identifying where the sowing is happening, right? Now, if you go further during the vegetative stage, right, this is where you can understand what type of crop it was looking at, because every crop has a distinct signature, right? Either you do it manually or either you do it using a beefier or a fancier machine learning algorithm. At the end, both of them would do the same. Whereas if you go at the flowering stage, which is your peak of that curve, that is where your crop is getting matured in. And once you start dipping down, that is where the greenish color of a grain or a leaf goes into a brownish stage. This is where it's a time to harvest, right? Based on this curve, we are identifying how each pixel is behaving on the ground, what type of event that are happening. If there is a hazard, there will be dip in the curve, right? So you can literally map that as a digital twin using a remote sensing technique, but now to do it at scale. So just to give you an example, I think in the initial thing, Pradeep and Arpan would have emphasized the reason of using satellite data. It's always about large area analytics, right? It doesn't serve the purpose if you want to monitor just one single pixel or single feature as such. So in that whole thing, you need some beefy algorithm, beefy architecture to understand what's happening at each and every pixel, because you are literally dealing with crores of pixels over the period of time. And humanly, it's impossible to do it sitting on a standard software. That is where those complex algorithm comes into picture. So that's the life cycle we follow. That's one part of that. Now you generated a base data. Now, is it getting consumed in the same way what banks want during underwriting stage as such? There is a simple ask for them, is that please tell me what are the events that have happened, what type of crop it was, how much was the yield around it, if there was an event, what damage it did, right? So we are culminating everything to a score, which is generally giving you a capacity score of a farm. Now you have two set of information, one which your CIBIL gives, or any credit bureau gives, right? Which is the intent information of a farmer, whether he's willing to pay the loan back or not. But then what we are providing is, does he even have the ability to pay back? So this is how you start marrying, and this is where the decision intelligence start evolving and empowering them with right data point at right time of the decision making process.
So is it right to say that there are a lot of data which you get, right, raw data, but somebody has to translate that into a single or a few numbers for a particular use case, right? Otherwise you're just bombarding the customer or bombarding somebody like with so much data, because I can't understand this, right? Like now you're saying that we understand the use case and then we put it in a certain number or something where it is very meaningful for them, but all the processing, data, compute, models, algorithms happens. This is what the tech does, and this is just not satellite data combined with others. Pre-LLM era and post-LLM era, what has been the difference? Is there something which got unlocked?
Definitely, and it's not just what got unlocked. It is essential to understand how it got unlocked. As I told you, right? It's not just the architecture, why people are able to build those complex architecture. So LLM, right? It started with Gen AI, which is generative AI, right? What that basically means is the ability of an architecture to generate the signature on its own by learning based on certain patterns, right? But now how that has been enabled, the petabytes of data has went behind that to train those LLM models as such. The compute cost went down drastically. The amount of data that's getting captured, not just from the satellite data, but from different sources, was immense. Data was an oil, right? But then what are you going to do with that data? How are you going to do with that data? This is where the best part of what got unlocked was the compute aspect. The architecture of those compute aspect got changed. The ability to do it in a much more optimized manner. GPUs came. Initially we started with CPU, but then GPU came. Then VPU also came, which is your vision processing unit, which is very dedicated to just one set of vision processing algorithm that you could run. But then everything is getting utilized in some shape and form. So
a lot of people have heard about CPUs, GPUs, but GPUs are a very new concept. Can you give a practical example if something maybe which in Satsure you are using LLMs for, or VPUs for, or something like, okay, LLMs are there, we can do this use case, we can solve this problem, right? Or else you have not solved it, but there are possibilities which are lost.
So not per se we have used LLM as such, right? Because right now we don't have much of the utility on that aspect, but whereas the similar architecture is getting used in somewhere else, right? We have launched two important products. One was your super resolution. The other one is your Cygnus. During our Kharif season, technically, as what Akash was mentioning, Kharif being the monsoon season of India, optical data doesn't have the ability to penetrate the cloud cover. For that you need to use some other sensor data, which is something we call as microwave. Now microwave has the ability to penetrate the cloud cover, understand what are the features down there, but it's not the straightforward what you see in the color theory, right? RGB, red, green, blue, what human can interpret. It's a different ball game to interpret microwave data. Now how can we use it in our workflow, because it's a single channel data with different polarization as such, but it doesn't have the ability to tell me what sort of crop it was, or in matter of fact even to give the signature what we use as NDVI, right? This is where Gen AI came into picture. How can you do a domain transfer of a microwave data into a readable domain, which is your RGB, NIR, so on.
So basically it's just typical stuff that it's good at, right? Pattern recognition and translation. It's like language translation, but between microwave too.
But you're learning the signature from the microwave, but then you're translating that into this domain. Now it helps my analyst or my data scientist to use that as a data input to do further analysis, build other applications. That was one part which we got patented last year both in US and India, whereas the other one was super res. I am pretty sure Akash would throw more light on the high res data, whereas when it comes to high resolution data, it has a lot of challenges. First of all, we do not have active source which is open source technically
Yeah.
for a company like us to utilize that data. What you see on Google Map is just one single timestamp stitched image, but it's only good to identify the object. If you want to do further analysis, definitely you will not be able to do that. Whereas for us it's essential to tap into different applications, right? This is where we created our capability to resolve the 10 meter by 10 meter pixel of Sentinel-2 to 1 meter by 1 meter by increasing the information density, breaking that 10 meter by 10 meter pixel to 1 meter. Like something like what your DSLR does it for you, right?
Pixel binning.
Pixel binning and everything. But it's other way around. Binning is easier, but adding more information, looking at certain patterns, how the contextual information around that pixel would be, identify what sort of features. So it may looks simpler, but when it comes to the architecture point of view, it gets really difficult, right? So that was another. So Gen AI, from the LLM point of view, definitely we are not using it now, but definitely there are applications we're still exploring. But when it comes to the remote sensing, computer vision aspect, definitely we are using it.
Could you shed a little bit more light on resolution game as well, right? Like, of course, there's a lot of free and open source data that's at like 30 meters, if I'm not wrong, mostly available. But why do we need more high resolution imagery? What does it unlock in the whole market and to the value chain? And like, what are your efforts towards that as well?
So when we talk about resolution, most of the times in I would say general layman terms, we talk about spatial resolution.
Yes.
And when I say spatial resolution, it is all about what is the size of a feature or an object that we can identify or detect from space or even from drone. Like, I mean, resolution is a very common term for any imaging instrument or a remote sensing instrument. Okay, so we'll focus on the spatial resolution because you have spectral resolution as well, which is what Rashmit was talking about, different bands giving you different information, etc. So when you talk about spatial resolution, like you mentioned, we do have open source data available out there. 30 meters is by the Landsat data, which is by the US. And then you have the 10 meters open data by the European Space Agency's Copernicus program, Sentinel series of satellites. India, I think India has made available the 5 meter data as open source data, which is from the LIS-4 sensor. The ResourceSat data as well. So that is also now open source as well. So the trend that we are seeing is for more and more urban related applications where you have urban features to identify and detect. That is where higher resolution comes into picture. Okay.
And these could be, for example, is it safe to assume like your street lights, your tree cover? What are some of these? What are some of these things that could be benefited with higher resolution?
So when you talk about high resolution, as of now in the industry, any data which is 1 meter and below 1 meter GSD. When I say GSD, it's a ground sampling distance. So if you say a data which is of 1 meter resolution, that means you can easily identify any object which is roughly 2 meters. Like, we have a thumb rule. Like, if you take any object of 2 meters, you can identify and classify that object with a 1 meter data. If you just want to say that, okay, like there is an object here of 1 meter, that you can do with a 1 meter data as well. So in the industry, there are a lot of satellite operators who are pushing towards very high resolution as well. Very high resolution category comes 50 centimeters or lower than 50 centimeter resolution. Most of it is, as of now, predominantly used for defense use cases. But considering a lot of commercial satellite operators coming into picture, companies like SatSure, like where we are developing commercial use cases, we are seeing that a lot of commercial use cases from high resolution data as well. So examples like we can now detect the rate of urbanization within a city, right, with the high resolution data.
That being how fastly the city is growing, where is it growing?
Yes, how fast the city is going, like what is the urban cover within the city. Like you can detect the building footprints very accurately, identify, okay, if you take an area of 500 square kilometer, within 500 square kilometer, mostly the tree cover might be only very less. The 80% might be of building cover, right? So in fact, SatSure is, we are working with NIC where we are detecting building footprints, but that is being done with drones as of now. because drones have higher resolution.
Yes.
And there was a customer requirement of the accuracy of the detection as well, because in drones we are talking in the orders of centimeters,
Yes.
not even meters, right? So depending upon applications and end users, high resolution, I mean, we have to decide to what level of high resolution data that we need to use.
And also, like you have mentioned, like the monitoring urban, right? Like taking back to the conversation as well, like data as that parcel itself is not useful, right? How multiple sources of data combine together. So, is it safe to say, like, you are tracking urbanization as well as how is it impacting other metrics, like how is it impacting your tree cover? How is it like encroaching a piece of natural drain or like water body, etc. So is that something that you see being like a crucial step towards the future, or?
Yes, and this is already being done. I think when there was the floods in Bangalore due to the rain, not the recent one, the one before that, there were a lot of news articles who like scraped the satellite data, and they found out that the buildings were built where there were lakes some 20 years back.
Yes.
Right? I mean, lakes are drying up because of climate change or a lot of different reasons. Using satellite data, you are now able to go back in the time and say like, okay, like where are we building? How will that affect the urban environment or the people around us, right? So yes, like, I mean, this is definitely useful.
Moving now to the talent side of things, right? Like, how can somebody who's just going to college or moving out of college can think about a career in this field?
Yeah.
Like, how can they start dabbling before, so that they get curious, they get inquisitive, right? Like, somebody, like, for example, starts to dabble, they generate more interest, and it also builds the talent pipeline and also gives us a current sense of how is the talent pipeline looking for.
So within the upstream side, where I'm mostly focused on, right, we have a combination of electronics engineers, mechanical engineers, optical engineers, thermal engineers, and generalists who we call them as systems engineer, like who know a little bit of each and everything. So it is a combination of all these domains coming together and building a system like a camera or a high resolution camera payload that we want to put on a satellite. So if we just have an aerospace engineer, while yes, aerospace engineer is important, but just alone aerospace engineer will not be sufficient to build anything of such sort. So I would say my go-to advice to a person in a college, be it electronics engineer or mechanical engineer, start reading things about what can you contribute, or how does electronics fit into space, or how does mechanics fit into space.
Some resources or best easy ways to start. I think the starting point is the friction, right? Like, how can we ease that transition?
Easing the transition, best thing is intern in any one of the space tech companies. You get to understand what the field looks like, and fortunately now we have private space ecosystem where you can actually go and do an internship. When I started my career, that was back in ISRO in 2013. There was not even one private company in India where I could do an intern to even understand, okay, like how does it look like, right? That would be the easiest transition, I would say.
How does it look like more on like the downstream side, like even in terms of data once you get it back, like in terms of traditionally, where do engineers come in and what kind of?
That's a great question. That is something we also trying to answer to ourselves from past 7 years, right? So it's not that easy, right? Someone who is coming from the software domain or data science domain to understand the remote sensing or a GIS aspect, right? It's a separate course, separate, I would say, dynamics are completely different. They're built different, right? The understanding is different here. That is why even from the Satsure application side, right, our tech teams are divided into the four buckets technically. One, geospatial data analyst or geospatial scientist, I would call them. Then your software engineers. Third would be a data scientist. And then the new role that is getting evolving now, the ML engineers, ML researchers, or AI engineers, right? So for us, the talent means that if you know something really well, come with that foundational knowledge. Rest over the period of experience and other things, you will learn. right? And I think that is what we also driving for. If you come with remote sensing knowledge, your fundamental has to be really good, and then you can learn something new in terms of how to automate things, how to build models, get into the data science domain. Whereas if you're coming from purely AML background, where you did not had the chance to work on remote sensing or GIS domain as such, but you still have worked on imagery data, like the natural images as such, it gets easier. Okay, but definitely you need to spend some time to understand how remote sensing works. It may look like an array of number, but the physics behind it is completely different, right? Because something what you see visually, how you interpret, right? Different band, different features, that is essential to understand, and that is where we also trying to bridge the gap in combining your geospatial domain to AML domain, right? Building rock stars, right, who understand both the side. But it's too much of us. We still long way to go, but then we are getting there. So for today's generation, I would say that if you're coming from software engineering background or a data or AML background, you need to keep your fundamentals really clear. If you are saying you're a software engineer, you need to understand, you have done it yourself, that you have built a scalable software. At the end of the day, that is what matters, to build an application.
Interesting. You have touched upon some agri use cases as well as some urban use cases. So what are the different kinds of projects that currently you are working on? What are the domains that you are tinkering with SatSure?
We have, I would say, a very deep penetration into the agri-finance ecosystem, where we are working with banks, as I mentioned. Indeed, a few of our investors are also large banks like HDFC and ICICI Bank. We are also very deeply involved with the aviation and the power lines, basically the critical infrastructure sector, and we work with organizations like Airport Authority of India, Adani Energy, for example, and also internationally in these domains. Things that we have started working in the last 1 year would include entire forest management aspect. Indeed, we have a partnership with Boston Consulting Group and JICA, which is Japanese International Cooperation Agency, where we are working with state governments like Rajasthan state government, for example, in establishing a complete digital stack for monitoring your forestry assets and also monetizing it in the future. That the money that goes into further, creating a sustainable conservation efforts on the forest and other natural resource part. Things that we are absolutely excited about and still building our, I would say, thesis through discoveries of different problems are obviously in the energy domain. So, for example, the transition to clean energy is a place where we have a bit of experience of how we are helping organizations identify the right locations for their biogas plants, solar plants, etc. How we are also enabling them more efficient way of putting up large infrastructure projects in these domains. And last but not the least, I would say for us a very important part of what space data can enable is the blue economy. While SatSure currently is not involved in that, which is the marine ecosystem, the conservation efforts there, as well as the overall supply chain of maritime traffic, etc. That's an exciting space, and with different kinds of data sets which are on oceanic plus information on the ships, boats, etc. All of this comes together, create even improved oceanic life. Yeah, these are some of the areas where we work with.
Interesting.
So we heard a lot from all of you guys. It's really insightful, right? Like now, to just close the things up, what are some real life problems which the community can solve for, where you think the community should come together and solve with the use of space tech, right? Maybe you can take few areas, themes, and maybe give us some insight so that the community gets motivated and comes together and solves these to start with.
Yeah, that's a great problem statement. Indeed, there are multiple things that can be done using data from space. Whether it is water conservation, it is the greenery of your city conservation, keeping a tab on your overall transportation systems and the pressure it is putting, the urban sprawl, the pressure it is putting on your transportation system, etc. So much of insights can be gained using space data, but the thing is that many a times these are not always very commercially viable in things. So companies may not want to invest their time into this, and this is where the community activities becomes very important. And I guess for that to happen, the awareness of what can be done using the data, what are the tools to actually use, then that's something which needs to be built more and more. There's so much of open data available, honestly, and there's so much of other tools such as mapping, map information, so many open libraries to extract data, run models, etc. is there. We can do wonders in any of these initiatives of that pertains to building more sustainable cities here, from both planning as well as maintenance perspective. The entire ecosystem of the city, not just the humans, but the traditional biodiversity amongst which we have, like the cities could coexist. We are literally the way in which we have urbanized is one at the cost of other. Humans at the cost of biodiversity, and or biodiversity at the cost of humans. It can be together, and for that we need to have better decision making frameworks for which data is there, and people. And as it boils down to people, finally, I think the awareness that there is so much you can do with space tech, that is something that we are trying to champion through this video.
No, I was about to ask, what can people and AI do?
People and AI can help us reach such a broad audience that we as Satsure would not have access to. I think if you can get people excited about the possibilities of using space technology towards better cities and better living, I think that's a big gain for all of us as a community. It not only helps us build awareness amongst people of how they can play a role in this, but also gets people more and more familiar with the use of such kind of data, which is going to only increase exponentially as we try to tackle the biggest problems on Earth using data from space.
You heard from Prateek what are the use cases and what are some problem statements and what they are also doing at SatSure, right? Now, let's form a community to actually see how we can harness this satellite data, satellite tech, right? And Pradeep and his team can actually lend their guidance so that the community goes bigger and bigger, and we aim to solve some real life problems, right? Like what can people and AI do? Let's answer that.